Welcome you all in the 13th lecture of Electronics Measurement and Instrumentation. This is the third lecture of CRO. In previous two lectures, I have discussed about the measurement of different quantities of an electrical signal, how to measure the signal's amplitude, the frequency, the time period, how we have to compare two signals by using Lissajous pattern. And in first lecture I have discussed about the front panel control. In this lecture I will discuss about the heart of the CRO, that is the cathode ray tube. So, cathode ray tube is a very essential part in a CRO. So, in this lecture I will give a brief introduction of CRO, the construction of cathode ray tube, that is CRT, the electrostatic focusing in CRT. Two types of focusings are generally used. One is electrostatic focusing and other is electromagnetic focusing. Electromagnetic focusing were done in old type of TV CRTs, and when the screen size is bigger, then electromagnetic focusing is done. But in CRT, since the cathode ray tube of the CRO, the screen size is small, it is approximately 100 mm by 100 mm. So, here we are using electrostatic focusing. Then we have to see the relationship between the deflection voltage and the deflection in y direction that takes place in the CRT. So, as we know, the CRO consists of the main part is CRT, then the vertical deflection system, the horizontal deflection system, time based generator, triggering circuit and power supply. The vertical deflection system, basically the input signal is applied at the vertical deflection system, and this vertical deflection system is responsible for the presentation of the input signal on the screen. Horizontal deflection system generally produces a time based circuit, sawtooth wave signal, and that signal will basically display the input signal on the x axis. So, horizontal deflection system is responsible for the reproduction of electrical signal at the x axis, and vertical deflection system is responsible for the signal reproduction of the signal at the y axis. Then there is time based generator and trigger circuit. These are used to synchronize the horizontal deflection system with the vertical deflection system, that is the time based generator system with the input signal. So, main part of the CRT is the electron gun assembly. Electron gun assembly, deflection plate assembly, fluorescent screen, glass envelope and the base of the CRT. In electron gun assembly, basic components are indirectly heated cathode, control grid, focusing anode, pre-accelerating and accelerating anode. A deflection plate system assembly consists of vertical deflection system and horizontal deflection system. The vertical deflection system is basically the signal amplitude, it defines the signal amplitude, and the vertical deflection system is placed, basically the vertical deflection system in CRT. There are a pair of plate which are placed horizontally like this way, and this pair of plate placed horizontally, and it controls the movement of electron in the vertical direction, means the electron will move in the vertical direction, but they are placed in horizontal direction. Similarly, horizontal deflection system in CRT, it has a pair of plate which are placed vertically like this way, and it controls the movement of electron in the x direction. Then there is fluorescent screen. The fluorescent screen the fluorescent screen produces basically it converts the electrons, that is the electrical signal that is passing through the electron into the fluorescent screen, means it represent it into the generation of the waveform on the screen. Then glass envelope is evacuated glass envelope inside which all the assemblies are placed. Base in general in CRT, all the connections are made through the base. Electron gun assembly has indirectly heated cathode, control grid, focusing anode, pre-accelerating anode and accelerating anode. In some CRT, the pre-accelerating anodes are missing and the focusing anode and accelerating anode is present. This is the diagram of the CRT, cathode ray tube. So, we can see here that it has electron gun assembly, then deflection plate assembly and then acceleration and screen. So, as we see from the diagram that this cathode is indirectly heated cathode, means there is we can see this is the heating element and it is and this is the cathode. This is the cathode and this is the indirectly heated cathode, means there is a filament which is heating the cathode. So, cathode has a very low work function, means if very small voltage is applied at the cathode, then this cathode will produce electron. So, it will emit electron and there is a control grid. All the cathode or control grid or accelerating, pre-accelerating anode and the focusing anode are made up of cylinder in shape. So, we can see here that the cathode is made up of cylinder in shape with a very small aperture at the end. So, it produces emits the electron from there. The control grid is kept at negative potential. So, the electrons that is produces by the cathode, whether that electron will move towards the screen or not, that is decided by this control grid. So, if we keep control grid, generally it is kept at -2 kilovolt. If we increase the potential at control grid more negative, then what will happen? Electrons are negatively charged and cathode is kept and this control grid is kept at negative. So, it will repel the electrons. So, by changing the voltage of the control grid, we can see this is the control grid voltage and it is variable voltage. So, the intensity or the brightness can be controlled by varying the voltage of the control grid. If we want more intense beam to be at the screen, then the control grid voltage should be less negative. Then there is a pre-accelerating and accelerating anode. Pre-accelerating and accelerating anodes are kept at high positive potential, approximately 200 watts or 200 volts, and because of this positive potential, the electron which is leaving the cathode will accelerate it and will move at very high velocity because of the positive potential. Positive potential attracts electron. So, pre-accelerating anode and accelerating anodes are kept at 2000 volt, whereas the focusing anode, which is in between the pre-accelerating and accelerating anode, as we can see in next slide, it is kept at 500 volt. So, because of this, these are attracting the electrons with the positive potential, and since accelerating anode is at positive potential, pre-accelerating anode is at positive potential and the focusing anode is in between that, and that focusing anode is if we say comparing with the accelerating and accelerating anode, pre-accelerating anode, it is at negative potential. So, the electron concave lens is formed there, as we can see in next slide. Then there is a deflection plate, pair of horizontal deflection plate and pair of vertical deflection plate. As we can see here, these are the pair of horizontal deflection plate that controls the movement of electron in the x direction, but they are kept vertically, and the vertical deflection plate that controls the movement of electron in y direction, they are kept horizontally. Then there is a screen. The function of a screen is to convert the electron that is impinging on the screen into the light energy. And so, this is also a diagram of picture tube. Here we can see that there is a pre-accelerating anode and accelerating anode. So, here we can see that all the accelerating, pre-accelerating and other anodes are cylinder in shape. So, indirectly heated cathode is also cylinder in shape, and to have a very low work function, means ki it can produce a large number of electron, it can emit a large number of electron at very low voltage, approximately 6.3 volt, and the current is 600 milliampere. For this, a barium and strontium oxide coating is deposited at the end. Similarly, control grid is coaxial with the CRT screen and coaxial with the cathode, and it is a nickel cylinder, and the length and dia of this nickel cylinder control grid is 15 mm by 15 mm, and it has an aperture of 0.25 mm at the center. So, control grid's basic function is to define the number of electrons that are going to strike on the screen. Then there is, we can see here, there is an aqueduct coating here, and there is a phosphor coating inside the glass. This screen is of glass, inside that glass there is a phosphor coating, and inside that phosphor coating there is an aluminum coating or any conducting material coating. So, here we can see that again focusing anode is of cylinder in shape, and it is kept at 500 volt. Focusing anode has a variable voltage. Here we can see that it is having a variable voltage. So, by varying the voltage of focusing anode, we can change the focus of the electron beam that is striking at the screen. Pre-accelerating and accelerating anode is kept at 1500 volt, and deflection plate, the vertical deflection system has to receive the signal from the input signal. The unknown signal is received by the vertical deflection system, and then it is fed to the vertical plates, and this horizontal deflection system receives signal from two sources, either from the unknown signal that is applied at the vertical deflection plate, or from the external sources such as horizontal amplifier and other external sources. Now, as I have discussed, this deflection plate assembly, if here this two plates which are placed horizontally and they are acting as a vertical deflection plates, pair of vertical deflection plate, and this plate, upper plate is kept, P1 plate is kept at positive potential with respect to P2 plate. So, what will happen, the electron which is leaving the pre-accelerating and accelerating anode are attracted by the upper plate, upper vertical plate. So, the electron is moving at this point and striking the screen at y1 point. If we reverse the battery terminal, then what will happen, it will strike at y2 point. Similarly, in second diagram we can see the this is the horizontal deflection plate, pair of horizontal deflection plate that are kept vertically, and they control the movement of electron in the x direction. Again, here we can see that this plate H2 is kept positive with respect to H1. So, the electron beam is moving on the x axis at x2 point, it is striking at the x2 point. If we change the polarity, then it will strike the x1 point. It means horizontal deflection plate basically controls the movement of electron in the x direction, and vertical deflection plate controls the movement of electron in the y direction. Fluorescent screen is generally just CRO we are using, that is of 100 mm by 100 mm, and if higher, if the size is more, then it is slightly curved at the end, so that the electron beam cover whole screen. And it is made by pressing molten glass, and inside surface of the screen is coated with the crystalline phosphor crystal coating of 2 to 3 micron thickness, and inside that the phosphor coating there is activator coating, conductor coating material is there, that is aluminum, silver, copper, chromium and all there. So, what is the need of aluminum layer? When electron strikes on the screen, on the phosphor, then what will happen, since electrons have very high velocity and when it strikes on the screen, then what will happen? It will generate some heat. If the heat is not dissipated, then what will happen? That area will be burned out. So, to stop burning, to avoid burning, we are using aluminum coating. So, aluminum or any conducting material, heat conducting material basically dissipate the heat into the atmosphere. Second, when the electron strikes, some of the electrons get covered, it means the electrons cover the screen, and then the next electron which is emitted from the cathode will not strike the screen, because there is a negative charge layer is there. So, that charge layer is also dissipated by the aluminum. And second, if the light is scattered, when the beam strikes the phosphor with the aluminized coating, the light emitted back, means when light is emitted back from the phosphor screen, it is again emitted back by the aluminum. Then there is an aqueduct coating, I have told in last slide. So, it is made up of aqueous solution and it is connected to the second anode, means positive voltage. Then if the electron strikes on the screen, the secondary emission electrons take place, and that secondary emission electrons are collected at the in front of the screen. So, they will repel the electron which is moving from the cathode to the screen. So, that electrons, because it is positive, it is connected with the positive charge. So, it will absorb all the electrons. So, aqueduct coating is used full for the collecting the secondary emission electron. Then glass envelope, evacuated glass envelope is there, and inside that all the components are there. Base are generally the connections are made, various parts of the connections are made from the CRT to the different part of CRO through the base. Power supply, high and low voltage power supplies are required. High voltage power supplies are required for the purpose of the voltage for the different type of anodes and cathode of the CRT, and low power supplies are used for the to supply different circuits of the CRO. For the if for example, amplifier, there are so many amplifiers, vertical amplifier, horizontal amplifier, then there is a delay circuit, triggering circuits are there. So, for to supply the voltage, we are using low voltage power supply. Then electrostatic focusing, as the screen of CRT is small, then electrostatic focusing is done. As we can see in figure, if we remember in from last slide, that there is the pre-accelerating and accelerating anodes are kept at positive potential, and the focusing anode is at with respect to accelerating and pre-accelerating anode, it is kept at negative potential. So, here it is shown that an electron which is at the rest position, this is placed here, and these are the two plates, one is minus E and other is placed as plus E. Suppose this is a pre-accelerating anode and this is our focusing anode. So, this electric field lines which moves from between these two, we see that they are moving straight line, but at the end they are curved like this way. So, if we connect all the equipotential surfaces, all the points that is at equal potential, then we will see the curved line at the end. So, the second diagram we can see that this is the focusing anode and this is the focusing anode and this is the pre-accelerating anode. So, what happened, there is these are the electric field lines which are curved at the end, and because of this the equipotential lines are also curved, because they are at 90 degree with this electrical field lines. So, these equipotential lines between pre-accelerating anode and focusing anode and from focusing to accelerating anode, they form electronic concave lens like this. Now, if the signal travels from one surface to other, then what will happen? We know that the sine of the angle of incident oblique sine of the angle of reflection is equivalent to the velocity of electron after leaving the surfaces divided by the initial velocity of the electron. Now, we have to find out the relationship between the deflection voltage means the input voltage that we are applied and the deflection takes place in the screen. So, here we can see that when the electron beam is leaving the accelerating anode, at that time the electron beam is moving in the x direction only and there is no acceleration force on that beam. But when the electron beam, since this deflecting plate, vertical deflecting plates is this is the upper plate is at plus ED and the lower plate is at 0 volt. So, the electron beam which is entering inside this deflecting plate will get attracted by the upper plate. Then at that time, if we see that at this portion, this is basically making it as a parabolic. This shape is parabolic till the completion of this plate. After this plate, it again moves in a straight line. So, here there is some portion which is of parabolic in nature and then it is moving straight. So, when we join this terminal, this point to this, if we draw a tangent to that parabolic, it will reach at this position. So, if we consider here that E A is the voltage of pre-accelerating anode, E is the charge of electron, m is the mass of electron, Vox is the velocity of electron when entering the field, Ed is the potential at deflecting plate and small d is the distance between the deflecting plate, L is the distance at the center from the center of plate to the screen and d is the deflection in y direction. Then when electron is entering in the deflection plate, vertical deflection plate, then it will lose the potential energy, that is P potential energy is equal to E into E A, and then that what the loss is in the potential energy, that is gained by the kinetic energy because of the energy conversion. Then the kinetic energy we can see half mv square. So, it is half mvox square. Then from these two equations we will get Vox is equal to 2 E charge on electron E A by m half square. So, now the electric field intensity in y direction epsilon y, that is equal to the voltage between the deflection plate, vertical deflection plate divided by the distance between the deflection plate. Now, the force acting on the electron F is equal to, we know, that is E into epsilon E, and by placing the value of epsilon y, it is E E d by d. Now, force acting is F is equal to m a mass into acceleration. So, by substituting this value we will get A y is equal to E epsilon y by m. Then as the initial velocity in y direction, when it enters under the deflection y deflection plate, then it will get the velocity in y direction, otherwise the velocity in y direction is 0. So, we know that y is equal to u t plus half a t square, but here u is 0. So, y is equal to half a y into t square, then by putting the value of a y we will get this. Now, we have to put the value of t square. Now, we know that the electron displacement in x direction is constant, there is no force acting. So, x is equal to Vox into t. So, from this we get the t is equal to x by Vox. Now, we putting the value of this t in this equation. Now, by putting the value we will get y is equal to half E epsilon y by m x Vox square, and we know this is the equation of parabola, and so when we draw slope of this point, we get dy by dx, we will differentiate it dy by dx and we will get this. Now, putting x is equal to Ld in the above equation, we will get tan theta is equal to this value, it is E Ed Ld by m d Vox square. So, after leaving the electrostatic plate, the electron will move in the straight line. So, if we see here x is equal to y by tan theta. So, now substituting the value of y and tan theta, we will get Ld by 2. So, now this value of x is substituting in the above equation. So, we will get d is equal to L tan theta is equal to this one, and after substituting all the values, we will get the deflection is equal to L E d Ld by 2 d Ea. Now, here if we see in this equation, the L is constant, Ld is constant, just d is constant, and for a particular value we will keep Ea, that is the voltage at accelerating plate, it is also constant. So, we see here that d is proportional to the Ed, that is the deflection voltage. So, we can conclude from the above equation, if we keep accelerating voltage constant and the dimension of CRT is constant, then the electron beam is directly proportional to the deflection voltage. In this discussion, we have there is in any equation there is not a portion of E by m ratio. It means the ion 1 is not there. There are two more terms, one is the deflection sensitivity. So, deflection sensitivity of the CRT is defined as the vertical deflection of the beam on the screen per unit deflection voltage. So, S is equal to d by Ed, and if we put the value of d by Ed, then we will get this value L Ld by 2 d Ea. So, sensitivity can be increased by decreasing the accelerating voltage Ea, but it will decrease the brightness of the spot on the screen. Then the deflection factor is 1 by S and we will get the deflection voltage. So, this is all about the CRT and how CRT works, how the deflection, the electrostatic deflection takes place, and how the input voltage is proportional to the deflection in y direction. Thank you all.